In this problem, I need to find the partial fraction decomposition of the rational expression x squared plus 5x plus 2 all over the factor x plus 1 times the factor x squared plus 24x plus 3. What it means to find the partial fraction decomposition of a rational expression is that we're going to rewrite one fraction as the sum of two or more fractions. In this case, it'll just be 2, because I just have two factors in my denominator. So I'm going to have, it really depends on the problem. In this case, it's two fractions because we have two factors in the denominator. And you'll see in other videos that that will change depending on the type of factors that you have. So let's get started with this. I'm going to take my fraction and move it over, make some room. All right. So I want to write this fraction as something that it's equal to, and I know that my two denominators are going to be x plus 1 and x squared plus 24x plus 3. Oops. 3. There we go. Okay. Right. So those are my two denominators, and what should my numerators then be? Keep in mind in these problems that the numerator is going to have 1 degree less than your denominator factor. So my denominator factor is x plus 1 in the first fraction, so my numerator then would be just a constant 1 degree less, so just a plain a. And it's an unknown number. It might be 1, it might be 7, it might be negative 13. We don't know yet. Now, the next denominator is quadratic. We couldn't factor it. If we could, then we would have done that already, and then we would have 3 linear factors in the denominator instead of 1 linear and 1 quadratic. So, since the numerator needs to have 1 degree less, I'm going to make it a linear factor, and it's going to be bx, because I don't know the coefficient of x, plus c, because I don't know what the constant term should be. So now I have 3 unknown quantities that are the constants. Now, of course, there's also x, which is unknown, but in terms of this problem, I have 3 unknown quantities that I need to discover, a, b, and c. So how will we go about doing this? Since I know that this first fraction that we started with needs to be equal to a over x plus 1 plus bx plus c all over x squared plus 2x plus, 24x plus 3, what I can do is multiply both sides by the common denominator. So I'll go ahead and do that. Now, I need to multiply on both sides. Ooh, I can't really fit that in there. All right, let's move things around a little bit. Move this over. Okay. So now, I'll put it above here. And I'm going to put in this factor 3 times. Squish it in there. Okay. So I've put in that factor 3 times because I have 3 fractions in my problem. So what I'll do is I will multiply this common denominator times the fraction on the left-hand side of the equation, and then I'll take that common factor and multiply it by the first fraction on the right-hand side, and then I'll take that common denominator and multiply it by the fraction, the second fraction, or the second term on the right-hand side. Okay, on the left-hand side, nice thing is everything cancels out in terms of the expression we just multiplied and the denominator that was there already. So now we're left with, on the left-hand side, x squared plus 5x plus 2. All right, and on the right-hand side, I can do some canceling as well. So the factor x plus 1 cancels with the factor x plus 1 in the denominator, and we end up with a times x squared plus 24x plus 3 plus, okay. So now I can do some canceling with my second term, bx plus c over x squared plus 24x plus 3. So that x squared plus 24x plus 3 cancels with the x squared plus 24x plus 3 factor that we just multiplied in. We still have the x plus 1. So now I have bx plus c, don't forget your numerator, times x plus 1. All right, just managed to squish that in. All right, so now I take this and I'm going to use some techniques in order to find out what A, B, and C are. So I'm going to get more space and we'll take a look at this in just a second. Now, one way to find our values of A, B, and C is to distribute and combine like terms where you can, and then set up a system of 3 equations and 3 unknowns. But there is what can be an easier way, and that's always a fallback, is to set up our system of 3 equations and 3 unknowns if we need to. But there is a little technique that you can use which can make life a lot easier. And here's what it is. This has to work no matter what value you have for x. So let's take advantage of that. I can let x equal anything I want to, and when I use certain values for x, it makes the problem a lot simpler. So first thing I'm going to do is I'm going to let x equal -1. Where did I come up with the value -1? What I did was I looked for a linear factor, and I have one here, right here, x plus 1 times the bx plus c, and I just, real briefly, you can just take that linear factor, set it equal to 0, and you can do this in your head most likely, but that's what I did, and I said x equals -1, and so I let x equal -1. All right, so what happens when I let x equal -1? Well, now I have -1 squared plus 5 times -1 plus 2 on the left, and on the right I have a times the quantity -1 in parentheses squared on the outside. Make sure you do that so that you get the right sign there, plus 24 times the -1 plus 3, close that parenthesis, plus open parenthesis, and we have b times a -1 plus c times, opening parentheses again, -1 plus 1. Here we go. Okay, so now we can simplify. -1 squared is 1, and then that's -5, which gives me -4, plus 2, that's a -2 for the left-hand side. And I can simplify what I have inside the parentheses next to the a. -1 squared is 1. 24 times a -1 is -24. So that's 1 minus 24 is negative 23. And then plus the 3 gives me a negative 20 times a. So now we have negative 20a. All right, so we have negative 2 equals negative 20a, and I still have to finish this off. I have b times negative 1 plus c, but that's multiplied by negative 1 plus 1. I had to write it underneath here, but it's really multiplied. So, since negative 1 plus 1 equals 0, and 0 times anything, even if I don't know what it is, 0 times anything at all equals 0. So that term just goes away entirely, which is great because now I can find a in about a half a second by just dividing both sides by negative 20. And I get a equals positive 1 over 10 in lowest terms. So now we have our value of a. So we have one value down and 2 to go. Let's take a look at what we can do next. In the last screen, we saw that a turns out to be 1 over 10. So I'm going to take my expression and rewrite it with a 1 over 10 substituted in. Now, what else could I let x equal that would make my life better? By being able to find b and c. So, what are some options? I could let x equal, let's see, what would be good? Well, I'm looking in particular at my bx plus c factor, and if x were equal to 0, then the b would go away altogether, which would be nice. So let's go ahead and do that. Let's let x equal 0. So when I substitute that in, I get 0 squared plus 5 times 0 plus 2 equals 1 over 10 times 0 squared plus 24 times 0 plus 3 plus, then we have b times 0 plus c times 0 plus 1. And I'm writing this out in a lot of detail because I know people are watching this. So you may be skipping a little bit of these steps, but make sure that you show substantially what it is that you're doing. You know, if you skip writing the 0 times b and you just say, oh, now that's c and it's c times 1, that's okay. But don't lose too many steps because then it just becomes, oh, and then I just magically knew the answer was whatever it is. So make sure that you're showing enough, but probably not in as much detail as what I'm doing here. And so we have 0 squared plus 5 times 0 plus 2, and that's of course just 2 equals 1 over 10 times, and then we have 0 squared plus 24 times 0 plus 3, simplifies to just a 3, so that's 1/10 times 3, plus b times 0 plus c is c, and that's times a 1. So I have 2 equals 3/10 plus c, and when I subtract 3/10 from both sides, I get c equals 2 minus 3 over 10, and you can bang that into your graphing calculator if you like, and this would be really 20 over 10 minus 3 over 10, so that gives me 17 over 10. Look at that. Now we have a value for c. Guess what? We're going to go to another screen. We still need to find b. All right. Here we go. So here's our expression again, and I am going to take out the a and, oops, I zoomed out. Oops, sorry. I'll zoom back in again. Well, let me write my fractions first. Okay. What was C? 17 over 10? Okay, 17 over 10. And A was 1 over 10. Okay, now I'll zoom back out so you can see the whole thing. Okay, so now I've plugged in A and C, and I need to find out what B is. And I've kind of run out of clever ideas for what to substitute in for x. We used -1, which made the x plus 1 equal to 0. Then I let x equal 0, which eliminated the b for the time being. So now I can really just actually plug in anything I want to, and I want it to be as easy as possible, because why would you make it harder if it could be easier? So I'm going to let x equal 1, because that's pretty much the only really easy number I have left. I've used -1 and 0. So I can let x equal 1. And because I really have only one unknown quantity left, that's going to work just fine. So I have x squared, so that's 1 squared, plus 5 times 1, plus 2 equals 1 over 10 times 1 squared plus 24 times 1 plus 3. Oops. Okay. Plus, and B, we still don't know what it is, times 1 plus 17 over 10 times 1 plus 1. All right, so we're not getting anything to zero out this time, which is a shame, but, you know, what are you going to do? So we have 1 squared plus 5 plus 2, so that makes 8 on the left-hand side, and 1 over 10 times 1 plus 24 is 25, plus 3 is 28 for that term, plus, and we have b times 1 plus 17 over 10 times 1 plus 1, which is 2. So now we're just going to finish solving this. This is just a nice little linear equation. 8 equals 28 over 10. And notice I'm not simplifying the 28 over 10. And I'm doing that on purpose for two reasons. One reason is because I already did this problem to make sure that I don't mess it up while I'm doing it on video. And the second reason is because even when I was doing it, I didn't simplify, because I kind of know after doing this for a long time that a lot of times you don't want to mess with your denominators when you have multiple fractions in a problem, because you can still combine stuff together a lot easier if you just leave it unsimplified. So I added together my 28 over 10 plus my 32 over 10, and I got 62 over 10. And so now I'm going to subtract the 62 over 10 from both sides, and that's going to give me, let's see, 8 would be 80 over 10, so that'll be 18 over 10 equals 2b. And let's see if we can squeeze this in. I'm going to zoom out again a little bit and just get some more room here. Okay. All right, so 18 over 10 equals 2b. That means that I need to multiply both sides by a half. And the 2 goes into 18 9 times, so we get b is 9 over 10. We are not done yet. Okay, so now we're going to go back to our original screen and we're going to plug in our solutions that we found. So b is 9 over 10, C was 17 over 10, and A was 1 over 10. So, all right, here we go. Let's get rid of some of this. I need space to write my answer. All right, let's see if I can remember all the things that they were. So A turned out to be 1 over 10, and I write that all over the x plus 1, plus, and then we have bx plus c, and b we just found was 9 over 10, and that's times x, plus, and c was 17 over 10, and I take that whole mess and I write it over x squared plus 24x plus 3. Now you might think, hey, we're not usually allowed to leave complex fractions in a problem and just say that's my answer, which I am right about to do. But when you enter this answer into my math lab is cool with it, so I guess we're cool with it. What you might do is you could multiply the numerator and denominator by 10. But the reason why we're not going to here is because you're going to use this in calculus. And when you do this in calculus, it's going to be, this is one step in a much longer problem, and so it's more convenient for us to just leave it the way it is here and then go ahead and do the rest of our problem. So that's why we're just cool with leaving it this way, and that's why my math lab is okay with that too. So I've got my final answer and I'm all done. It only took 21 minutes and 58. Okay, we're done.